In 1.3, we're going to talk about extrema and end behavior, like how a graph behaves and where is it headed towards. And extrema, as we're going to talk about here, extrema are basically just your maximum minimums. So the highest point, the lowest points on graphs. They're basically those turning points. Those are very important, and usually, especially in the real world, have certain meaning. We'll even see an example of that in just a minute here as well. So extrema is when we're talking about maximums and minimums. So I would just say, hey, I'm looking for some extrema, some maximums, some minimums. So you can see this graph has maybe some high points, some low points, and we'll talk about all those. A maximum is the highest point on the graph of a function. It may not have a maximum. Like if you look at this graph, there is no maximum point because it's endless. It keeps going up. So we're looking for turning points. So all these maximum minimums have to be turning points. It says it keeps going up. There is no maximum. There's no limit. Okay. This one here, though, has a maximum. It will never get higher than this point here. Keeps going down, so it doesn't have a minimum, but it does have a maximum. This minimum right here is definitely the lowest point on the graph. There's points that are definitely higher and keeps going up, so it has no maximum, but it does have a minimum. When we have a couple different turning points, we try to analyze it a little closer. A relative maximum or relative minimum is it's a located point on the graph where there's no other nearby points have a greater value or a lesser value. So for example, this point right here is a relative maximum. It's higher than the points nearby, but there are some other points that will be higher. When we think about this graph here, it's going to get higher. So there's not the highest point, but it's definitely higher than the other ones around it. It's at that turning point. On the flip side, this one here is a relative minimum because it is a low point, but there's other points that will be still lower. Okay, you can also see this one has a relative max, this one has a relative min as well. So we're just analyzing graphs, seeing what we can figure out. So if we look at this first fx function here, the function is decreasing as it approaches x equals 0. So x is 0 right here. As they're basically saying, as we go from like left to right, I know this is going up, but as you talk about left to right, the graph is actually decreasing. So it gets closer and closer here to this. So it's decreasing this way. And from the left, as we approach 0 from the other way, it increases as it moves away from 0. So it's increasing this way. It's decreasing, again, as we read the graph left to right. Okay, so that point 0, -5 is the lowest point. There's no part of this graph that's lower, so that is a minimum. This function g of x, now we're talking down here, it's increasing as we approach x equals -2. So here's -2. We're talking about this point. So it's increasing as I read left to right. It's increasing, then it's decreasing as it moves away from -2. There are no greater y coordinates surrounding it. However, it's not the highest point, right? This is not the highest point in the graph. There's other parts that'll be higher. So this would be a relative maximum. Same thing with this point over here. We're talking about, again, g of x. It's decreasing again, so it's decreasing as we get close to 0. Then it's increasing as it moves away from 0. So right around here, this is a lower point. It's lesser y coordinates here, but it's not the lowest point. There's other parts of the graph that are lower. So it's a relative minimum. We can also see that in the context of a real world problem. So here in a table kind of helps. So we have some actual values because it's hard to read the graph 100% accurate here. So at different times after midnight, release a number of posts in 100,000s. Okay, in 100,000s. So let's see if we can find any maxima. Okay, and we'll get into all these guys. So we're looking for the maximum is right up here. There's only one, like the highest point here, and that looks like it's set around 12 hours since midnight. So 12 hours after midnight is greater than the number of posts made at any other time. And this highest point on the graph occurs when x is 12, which means hours since midnight, so that happens at 12 p.m. It's hard to read this exact point, but if you look at the data, okay, 12 is at 11.5, that's in 100,000. So 11.5 times 100,000 is actually well over a million, of 1,150,000 posts. Is there a minimum? Okay, is there the lowest point of the graph right here? It's sent 4 hours after midnight. It's less than the number of posts made at any other time during the day. Looks like it's like heading lower even over here, but we don't have all the data here. And obviously we're just talking about one day. So they probably should have done an endpoint here, to be honest. It ends for the day. So right here, it's the lowest point on the graph for this real world situation. So that's at when x is 4, which is about 4 a.m. And if we look at the table, that's 1.8. So 1.8 100,000, or in other words, 180,000 posts. Is there a relative maximum? Yes. Over here, there's a high point, but it's not the highest point, right? It's a maximum. Looks like that occurs about 16 hours after midnight. It's greater than the other points nearby surrounding it, the surrounding times. So it's a relative peak when x is 16, which would be 16 hours after midnight, which would be 4 p.m. If we look at our data, 16 was at 10.2, so multiply by 100,000, so 1,020,000 posts. Last one is a relative minimum. There's a relative minimum right here between all this stuff here where it's about 14 hours after midnight because it's less than the surrounding times there, but it's not the lowest number sent. This graph dips when x is 14. We read our table. That's 9.1, so 910,000 posts. 14 hours after midnight would put you at 2 p.m. So we'll talk about end behavior next.